So here we are on how do power meters work part 3, okay? So we were just talking about a voltage divider and a current shunt. So this one would be all about a current shunt. And a current shunt is a low resistance device or a path that allows a portion of the electric current to flow around another component or part of a circuit, right? It's essentially a way for it to bypass for current. Okay, that's what we're really doing with this. And this right here in the center is the shunt. All right. And what's beautiful about this is that it says it's 0 ohms, but it's not, right? We just talked about in the last video. This could be, this shunt is designed to be 0.001 ohms, which means that it has a measurable voltage drop across it. And if we took a very sensitive voltage meter and applied it right here across these terminals, we would actually be able to measure that voltage. What if we just changed the scale on that meter to amps, right? And then we could figure that out, right? So that's essentially what we're doing with this voltage or this shunt, okay? It's a shunt resistor. This is what shunts look like. And, as you can see, the beefier that you have right here, that's going to be running more current, right? And it's extremely important to understand that when you look at these are your main terminals for connection right here. And then when you hook up that little meter that we showed right here in the bottom, right? This little meter, that's going to hook up to these tiny little terminals right here, okay? Don't drill into these and make your own little taps. These are practically calibrated devices. Even current calibration labs will still use these, and these are calibrated points. Okay, so they're put in a very specific spot, and don't go drilling and making your own taps on these. Okay, so when you see these, they could be in current ratings, and you might be able to see this. I'm going to zoom in on this if I can. See this right here? It's 100 amps per 100 millivolts, right? And then this one is 50 amps for 50 millivolts. Don't assume it's always going to be a ratio like that, where this is, 100 amps divided by 100 millivolts, and that ratio is the same as this one over here. Don't assume that's the same ratio. I have shunts in my arsenal that are 500 amps at 75 millivolts, okay? There are often these millivolt ranges, which are also listed down here, are anywhere from 50 to 75 to 100, and they're usually paired with a meter that is rated at the same voltage. Okay, and then this is not a comprehensive list of currents. They could be 1 amp. It could be the 2000 amp shunts, 5000 amp shunts. There's a lot of them. Okay. But this is generally how they look. And so when we apply this in a circuit, well, what could we end up doing, right? Well, say we had a shunt that was rated at 1000 amps at 75 millivolts. It has a known resistance. And this is basically a calibrated device that where you divide the 75 millivolts by 1000 amps, what you get is well, let's move the decimal point. That's milli. Let's move it another. That's 75 micro ohms of resistance. That's what that thing is, okay? And so what's beautiful about this is a 1000 amp shunt where, if you have a load running 1000 amps, that's a lot of current. If you had a 480 volt circuit at 1000 amps, just do the math on that real quick. A 480 volt circuit divided by 1000 amps, right? That load to, it's 480 volts. The load appears like 0.48 ohms, right? That's how you get 1000 amps out of 480. Okay. The load is so low in resistance that it draws 1000 amps, and it's about 0.48 ohms or 480 milliohms. And so this 75 micro ohms is still much less than this, right? And so it becomes negligible in the circuit. All right. So if you installed this shunt in a circuit that was running 400 amps, right, then it would be 75 micro ohms times your 400 amps. and then this shunt would have a voltage drop of 0.03 volts or 30 millivolts, right? And if we go back to this last one, what if we had a 50 millivolt full scale meter? Well, that would be an analog meter where when it points full left, it's 0 millivolts. When it points full right, it's 50 millivolts, right? So this meter would be reading somewhere about right here, 60% of the way up. You would get up to almost 700 amps of full scale deflection if you were using that scale of a meter. Okay, so this is how shunts primarily were used. They're still used a little bit, but back in the day, these were used heavily to construct our current circuits. So last notes, this is a calibrated measurement device. This is installed in series with the load, and you must connect to these screw terminals properly in order for it to accurately meter. Okay. And just as a side note, these little bars that you see between them, these are your your quote calculated resistances. Okay, these are designed to have only a certain amount of resistance. So hopefully, this clears some shunt business up. Let's get on to the next one.